Good day, everyone, and welcome to Physics Base Camp. I'm Zane, and this video is about unit prefixes in physics. Measuring things in physics is beyond important, and unit prefixes are things that help us do just that. However, I recommend you watch my previous video on the basics of units and quantities, if you have not yet done so, as that video explains the pure fundamentals, whereas this video rather builds on such fundamentals, so feel free to check that out if you'd like. That said though, in this video, you should get a solid understanding of what unit prefixes are, and how to use them, along with a number of other things. As always, if you have any questions or feedback on this video, or just in general, feel absolutely free to leave a comment below. I always appreciate both. But now, let's dive into the idea of unit prefixes. Okay, let's begin with a question. Do you recall how in my previous video I mentioned that every quantity is measured in a single unit, known as a quantity's SI unit? Well, here is my question, using the quantity time as an example. The SI unit for time is seconds. Remember that for a moment. And yet, what if we are dealing with an extremely large amount of time, as in maybe days or even weeks? How are we supposed to measure such large periods of time in seconds? Or maybe we're dealing with a super small amount of time. How are we supposed to measure these periods in seconds when they are such large or such small amounts of time? Well, solution 1. We'd have to write out these huge numbers, or numbers with so many decimals, like 2 million seconds, or 0.0003 seconds. But that's just so ridiculous, isn't it? I mean, you can write out these huge values if you want to, but can you imagine measuring a time period that takes years in seconds? That's just such a hassle, and yet we still have to measure time in seconds. Because remember, seconds is the SI unit of time, and we cannot just disregard that when we want to. So, what's the solution? How do we measure a quantity with its SI unit when we are measuring a very big or very small amount of that quantity? Well, ladies and gentlemen, that is precisely where unit prefixes come in and save the day. A prefix is a word or symbol we place with a unit to basically make the value bigger or smaller without changing the name or meaning of that unit. Now I can imagine that sounds very complicated, so let's take a moment and look at an example before I fully explain all the different prefixes. In this example, the prefix we will be using is kilo. Kilo is the name of this prefix. Now we always put our prefix with our unit, right next to it in fact, to show we are using that prefix. Any prefix also has two other components: its symbol, which for kilo is the lowercase letter k, and its meaning, or multiplier, which for kilo is 10 to the third, or 1,000. A prefix will take this multiplier and essentially will multiply the number it's with by that value. Kilo has a multiplier of 1,000, so it multiplies the value we put it with by 1,000. So 5 seconds, for example, obviously means 5 seconds, but 5 kiloseconds is 5,000 seconds, because kilo tells us multiply our value by its multiplier. 5 kiloseconds means 5 times 1,000 seconds, because again, kilo tells us we're multiplying our 5 by 1,000, giving us 5,000. This is super helpful, because now we don't have to write out or say 5,000 every single time. We can just say 5 kiloseconds. This makes our value quick and concise, and is a concept used very often throughout physics. But what about kilo's symbol, K? What's the purpose of that? Well, if you watched my previous video, you know that sometimes we don't always say the whole name of a unit. We sometimes just say a symbol, like 5,000 s instead of 5,000 seconds, because S is the symbol of seconds. When that's the case, then we can do the same thing with our prefix. We can say 5 ks rather than 5 kiloseconds, because we remember k is the symbol of kilo and s is the symbol of seconds. Basically, instead of writing out kiloseconds, we can, if we want, just replace the prefix and unit with their symbols. Both options work the exact same way though. The symbol just makes the whole thing less wordy, so not too complicated, right? We have our prefix name, which we can put next to a unit name, and our prefix symbol, which we can put next to a unit symbol, both of which multiply the numeric value by the multiplier with that prefix, which in the case of kilo is 1,000, rather than writing out a big number. And also, keep in mind, we can put a prefix like kilo before any quantity too, not just seconds. Maybe you have kilometers, kilograms, or really any quantity you want, since seconds was just the example I used right here. So now that we know how prefixes function, let's look at the first of 3 simple processes we'll be checking out today. How to add a prefix to a value. We already saw how they work. The multiplier multiplies the value by its given amount. But if I already have a value and I want to add a prefix to it, how would I go about doing that without changing the value? And also, to clarify what I mean when I say without changing the value, is without changing the meaning of the value. It might be a different number, but it will mean the same thing. Just like 12 inches and 1 foot. They may look different, but they both mean the same thing. So, that said, let's see how we go about giving a value a prefix without changing that value's meaning. Let's say the value we want to add a prefix to is, say, 13,000 seconds. Now I'm going to choose the prefix I want, and I want to use kilo again. So let's say the prefix we will be giving this value is kilo. The first step is to take my value, my 13,000, and divide it by the multiplier, the 1,000. So we're going to bring this 1,000 down here and divide the value by the multiplier, the 13,000 by the 1,000. And that's pretty simple math. We get 13. Now we're nearly done. For step 2, the final step, all we do is take that number we got from the division, our 13, and then simply put the prefix we used and the unit after that number. So let's go ahead and do that. Put our kilo prefix and seconds unit right there, and boom, that's it. We now have our transform value 13 kiloseconds. This 13 kiloseconds is another way of saying 13,000 seconds, though it has a prefix, making it much more concise. So, to briefly recap all this, all we did to add a prefix to a value was divide the value we wanted by the multiplier of the prefix, value over multiplier, and then add the prefix and unit after the number we got. So now, you should have a pretty good idea of how these prefixes work. We can put them with our units to make the values with those units bigger or smaller. I already showed you how the prefix kilo works. But what about all the others? Because kilo certainly isn't the only prefix. Well, as you see on your screen, we also have all these other prefixes too, and they all work in the exact same way as kilo, except they just have different symbols and multipliers. For example, the prefix nano is represented with the lowercase letter n, where with kilo it was k. Nano also has a multiplier of 10 to the negative 9th, whereas kilo had 10 to the 3rd. Thus again, on your screen, you have a table of nearly all the prefixes you will come across, and they all work the same way kilo did in the previous example. They all have multipliers that multiply the values. They are all put next to a unit, they all have symbols, and so on. As always, feel free to pause the video and take a moment to understand this if you need to, or just take a look at the different prefixes in this chart. A link to an image of this chart will be available in the description as a reference for those who want it. Okay, so now we learned a bit about what a prefix is, and some of the ones we can use. Also learning how to give a value a prefix. But also, when we have a certain value using a prefix, it is very, very simple to convert or switch that into a different prefix, also without changing the value. Basically, it's quite easy to switch between prefixes, or convert one into another. This is the second of the 3 processes we'll be learning today, and all we have to do for this one is move the decimal point of our value based on the multipliers of the prefixes. But what does that even mean? Well, if I had, for example, 20 kilometers, and I wanted to see how much that 20 kilometers is in megameters, then to do this, I would first look at the multipliers of those 2 prefixes. Kilo has a multiplier of 10 to the 3rd, or 1,000, and mega has 10 to the 6th, or 1 million. Once you've identified these multipliers, focus on their exponents, the 3 and the 6 in this case. What you have to do for this second step is find how many numbers it takes to get from the first original exponent, our 3, to the second exponent, our 6. This is pretty simple. In this case, we just have to add 3, because 3 plus 3 is obviously 6. It took 3 to get from our original exponent to our new exponent. Now let's hold on to this plus 3 that it took, and go to the next step, where it may be a bit confusing at first. For our third step, we now move the original value's decimal point, that many spaces, 3 spaces in this example. We're essentially moving the decimal between the digits. So we'd move this decimal point 3 spaces to the left, as you see on your screen. We moved to the left because it was plus 3 spaces, not minus 3 spaces. We had to add 3, plus 3 to get from 3 to 6, not subtract 3. If we were subtracting 3, we'd move the decimal to the right. But by moving this 3 spaces to the left, as you see on your screen, we get a new number, 0.02, because the decimal point is now located in a different spot. This new number is our answer, in megameters. So our original 20 kilometers is actually 0.02 megameters. They both refer to the same distance, but with different prefixes and values. To wrap this part up, with this process, we quickly converted a number of kilometers into a number of megameters without using a calculator at all. We accomplished this by finding the difference in the prefix's exponents and then moving the decimal of our value accordingly. We can do this between any 2 prefixes. Just keep in mind whether you are adding to find the difference or subtracting. Here, we added 3 to get to 6, meaning we moved the decimal to the left. But if you subtracted, remember you'd move it to the right instead. Now, this process can be a bit tricky at first, so don't worry if you're a little iffy on it. We'll be using it in the next few examples. That way we all get the hang of it. But now, before we go on to those examples, let's learn the last bit of this lesson and take a look at the third and final step-by-step process, how to remove a prefix. This will put our value back into its base SI unit without any prefixes, and without, of course, changing the value itself. But before we learn how to do that, let me tell you a bit about why you might want to do that. Why would we want to remove a prefix in the first place? Well, prefixes are obviously immensely useful in a ton of subjects. However, in physics, we have many formulas that we use to solve for different quantities, and we cannot use prefixes in these formulas. Like, when you input a value into a formula to solve for a different value, that value you input can't use a prefix. This is because a prefix would change the number. It would change the value we input and give us an incorrect answer. So, make sure to stay with a quantity's SI unit with no prefix when you are using formulas. After you get your answer, maybe you want to put a prefix on that answer. But before you get it, I recommend that you don't use any prefixes, despite how useful they are, which is why this process on removing a prefix is vital. So, how do we go about removing a prefix? Remember, we can give a value a prefix by dividing the value by the multiplier, and then adding the unit and whatnot. So, to remove a prefix, we just reverse this process. We first take our value with a prefix that we want to remove, say 100 kilometers, and then, instead of dividing by the multiplier, we do the opposite. We multiply the value by the multiplier. We're trying to remove the kilo from 100 kilometers, and we know kilo's multiplier is 1,000. So we take that 1,000 and multiply it by our value, our 100. 100 times 1,000 is just 100,000. And with this new number, we can just add the regular unit now, without the prefix. For our example, we just add the word meters to our new number, without kilo. This means that 100,000 meters is the same as 100 kilometers. One just uses a prefix, and the other does not. We've basically completed our lesson on prefixes. We know what they are, how they work, a ton of the ones we can use, how to add them to a value, remove them, and even switch between them. The only thing left is some practice. So now, let's solve a few different problems that reflect what we've learned so far in the video. The first question we'll be taking a look at is how many meters are in 12.5 megameters. Feel free to pause the video and try to solve this on your own first. Okay, let's first figure out what process we actually have to use. We obviously aren't trying to add a prefix, since this already has one. We aren't switching it either, because we don't want a prefix in our answer. We see the question asks for normal meters, not millimeters or hectometers or anything. The question just asks us for the base unit. So what this tells me is that we want to remove the prefix, so we can see how many meters 12.5 megameters is. That said, let's try and remove this prefix mega. To remove a prefix without changing the meaning of our value, we recall that we just multiply the current value by the multiplier of that prefix. So let's do that. We see mega means 1 million. So let's multiply 12.5 by 1 million. We get 12.5 million. So basically, 12.5 million meters equals 12.5 megameters. Example 1 has been solved. Now, let's move on to our second question. How many micrometers are in 6 millimeters? Let's again figure out which of the three processes we'll be using. It looks like we are trying to go from one prefix, micrometers, to another, millimeters, which tells me we aren't adding prefixes or even removing them. We're trying to switch between them in order to convert milli into micro. We remember that for this, we must move our decimal point. Let's pull up the steps we have to take so we can slowly check them off. First step, identify the multipliers. Our original multiplier is 10 to the negative third, because we are starting off with the prefix milli, and our new multiplier is the one for micro, 10 to the negative sixth. Our next step is to see what it takes to get from our original exponent to the new exponent, to get from negative 3 to negative 6. Not too difficult. We have to subtract 3. Minus 3 to get from negative 3 to negative 6. Since we are subtracting, we see that we take our value and move the decimal point that many spaces to the right. So let's go ahead and do that. We now have the new number, 6,000, and that's it. We just go ahead and add micrometers to that 6,000, and we get 6,000 micrometers. There are 6,000 micrometers in 6 millimeters. Example 2 has been solved. And now, let's solve one final question, or rather perform this task. Give 3 billion seconds a prefix. This goal is quite straightforward. We have to simply add a prefix to 3 billion seconds. We can technically use any of the prefixes in this chart in front of us, but let's use the one that makes the most sense. We see our number is in the billions, so let's also use a prefix in the billions, specifically tera. To give our 3 billion seconds a prefix, we just divide that value by the multiplier of our prefix. Value over multiplier. So let's take our value, 3 billion, and divide it by tera's multiplier, 1 billion. Our answer is quite simple, 3. Now we just add this new prefix and our unit, teraseconds. So 3 teraseconds equals 3 billion seconds. And that's it. As this video draws to a close, I truly hope you gained a strong understanding, or at least a foundation, of how prefixes are used in physics, where you can continue to build on this understanding through your own research, or in future videos. So stay tuned for future things posted, and be sure to check out some of my previous videos too. Additionally, do consider leaving a like and subscribing if you enjoyed. It is deeply appreciated and helps support the channel. But that said, thank you for watching Physics Space Camp, and have a wonderful, wonderful day.